welcome to another lesson on Make Science Easy. Today, we're going to be doing some more work on scientific literacy. In today's lesson, we're going to be looking at basic math skills for science. Now, this is a really important lesson because we're going to be covering some of the key mathematical ideas that you really need to understand in order to do science. If your math skills are excellent and you have no problem with maths, you might find a lot of this information to be stuff you already know, in which case that's fine. But if maths is an area you find challenging, then this is definitely a really good lesson for you to help you understand some of the key points. The essential skills that we need to know for maths are being able to add, subtract, divide, multiply, being able to calculate averages, using decimals and fractions, being able to calculate percentages and ratios, understanding how to convert units from one type of unit to another, using standard form for positive and negative indices, using significant figures, drawing and interpreting charts and graphs, understanding the terms curve, angle, radius, diameter and circumference, these are all circle terms, and being able to rearrange simple equations. I'm not going to go through all of these things in this lesson, but these are the things that you need to know. The first thing is actually how to write numbers. Now this might seem very obvious, but we need to make sure we get it right. So, numbers that are larger than 4 digits, so any number bigger than 9,999, need to be broken up into threes. This makes them easier to read. So, we've got the number 1 million here. It's not broken up at all. It's wrong. But we can have a million written like this. Now this is correct because it's broken up into threes. The last 3 digits, the next 3 digits, and the first digit. So we work backwards. Or we can write it like this. It's exactly the same. The main difference is we've used commas. Now be very careful here. Depending on where in the world you're from, this isn't always correct. It is correct in this example, but some parts of the world use commas instead of decimal places. So the middle answer is often preferable. We also need to make sure that we know how to round, and in science, the general level of accuracy we need to work to is 2 decimal places. So, if I get a result that is 8.78863, that's a great level of accuracy, but more often than not, we don't need it. So we're going to say this is wrong. I mean, it's not a wrong number, it's a great number, but we often want to round for simplicity, so to 2 decimal places. So do we round it to 8.78? After all, 7 and 8 are the 2 numbers after the decimal? Well, the answer is no. In this example, we need to round up to 8.79. So the correct answer here is going to be 8.79. The reasoning for this is the third number after the decimal is an 8. If you have a 5, 6, 7, 8 or a 9, you round up, so at 8.79. If it was 8.784, we would round down to 8.78. So make sure you know when to round up and when to round down. Now, if we have a number that is less than 1, we need to make sure we're writing to 2 significant figures and that again we round correctly. So let's have another look at an example. 0.00755. A really detailed answer, but for the most part we only need it to be to 2 significant figures. Significant figures are numbers that are not zeros. So this is going to be incorrect in most cases. So when we round it, we could round it to 0.0075. The 75 are the next 2 significant figures. But is this correct? Well, let's have another look at our original number, 0.00755. The third number, the third significant figure, is a 5. A number of 5 or higher means we round up. So this is incorrect. It should be 0.0076 because we're rounding up. Make sure you know when to round up and when to round down. Our next important skill is being able to calculate averages. And you often need to calculate averages when you're using experimental data. There are 3 types of average we need to know: the mean, the mode, and the median. 9 times out of 10, the mean is the type of average you're going to be using. The mean. The mean is the sum of all of the results divided by the number of data points there are. So we can show this with an equation. Mean equals sum of data divided by number of data points. And we've got a data table here. It's irrelevant what this data actually is, it's just an example. But we see we've got numbers 12, 54, 17, 6, 25, 36 and 6. So in order to calculate the mean, the first thing we need to do is we need to add all of these data points together. So in this case, the mean is going to be 12 plus 54 plus 17 plus 6 plus 25 plus 36 plus 6 divided by 7. I've put those numbers in brackets because we have order of operations. Numbers in brackets or in parentheses always come first. So when we add them all up, we see the number is 156. This is much more useful than having lots of individual numbers. And we now divide it by 7. So in this particular example, the mean is 22.29. Now if you do this calculation yourself, you'll see that isn't completely the correct answer because I've rounded it. The second type of average we're going to calculate is the median. Now just to compare this, we're going to use the same data set and we're going to see how the median is different. The first thing you need to know about the median, it's the middle number in a set of data. So we need to order our data into numerical order, smallest number to largest number. So here we have it 6, 6, 12, 17, 25, 36, 54. Smallest to largest. And the number 17 is our middle data point. There are 3 numbers before and 3 numbers after. So 17 is the median number as there are 3 smaller data points and 3 larger data points. Immediately, we can see the median gives a very different answer to the mean. All of our averages are going to give different answers. As I said, you need to know when to use each one. Most of the time, it is going to be the mean. The final type of average we're going to calculate is the mode. Again, we're using the same data just to show you how they're different. So, the mode is the most frequently appearing data point. In this particular example, the mode number is going to be the number 6 as it appears twice. All other numbers only appear once, so the number that comes up the most frequently is the mode. So all 3 different types of average give a different number. The mean was 22.29, the median was 17, the mode was 6. Using the same data, we have 3 very different averages. A really vital skill is converting units. Common units are often used in science and need to be converted between one and another. It's normally done by multiplication or division. As a rule, converting a smaller unit to a larger unit requires division. So if we want to convert seconds to minute, we divide. Converting a larger unit to a smaller unit requires multiplication. So minutes to second, we multiply. Now, really important here, only standard units should be used. Now, what this means, say we're talking about speed in science, we might use meters per second or kilometers an hour. These are standard units. We would not use miles per hour. Miles are not a standard unit. So, metric units, not imperial. Always, always, always metric in science. So, let's have an example of converting time. Say we start with minutes and we want to go down to seconds. How are we going to do that? Well, what we need to think about is in 1 minute there are 60 seconds. So if I have 1 minute, I need to multiply it by 60 to get down to seconds. On the other hand, if I want to go from seconds to minutes, I'm going to need to divide by 60. If I have 120 seconds, I divide it by 60, I get 2 minutes. On the other hand, I might want to go from minutes to hours. Because I'm going up a unit, I'm going to be dividing. Because there are 60 minutes in an hour, I'm going to be dividing by 60. If I want to convert hours to minutes, I need to multiply. And I'm going to multiply by 60 because there are 60 minutes in an hour. Now, I may want to convert seconds into hours. Again, it's going to be a division because I'm increasing the size of my units. I'm going from seconds, very small units, to hours, very large units. So it must be a division. And the way I would work it out, I can see to go from seconds to minutes, I need to divide by 60. And minutes to hours, I need to divide by 60. So 60 times 60 is 3,600. So I divide by 3,600 to go from seconds to hours. To go from hours to seconds, again, I'm going to multiply, and it's going to be by the same amount, by 3,600. So an example of this, to convert 1,800 seconds to minutes, I look at my table. I can see seconds to minutes is divided by 60. So 1,800 divided by 60 is 30 minutes. If I wanted to convert 1,800 seconds to hours, I would do 1,800 divided by 3,600, so half an hour. To convert 3 hours to seconds, it's 3 hours times 3,600, which equals 10,800 seconds. Another example of this is converting mass. So let's start with the standard unit of kilograms. If I want to go to grams, there are 1,000 grams in a kilogram, so I multiply by 1,000. To go back to kilograms, I must divide by 1,000. Kilograms to tons, there are 1,000 kilograms in a ton, so I divide by 1,000. Going from tons to kilograms, I must multiply by 1,000. So, how do I get from grams to tons? Well, it's 1,000 times 1,000, which is 1,000,000. So to go from grams to tons, I must divide by 1,000,000. To go from tons to grams, I must multiply by 1,000,000. And we can always follow these rules when we're converting. Some conversions are a bit more complicated, but they generally follow the same pattern. Ratios are really important in science. A ratio tells us the relative proportions of different things. So let's look at an example of a chemical, sulfuric acid. It has the formula H2SO4. There are 3 elements in here, hydrogen, sulfur, and oxygen. So we need to look at the ratio of them. We can see there are 2 hydrogens, H2. There's 1 sulfur because there's no number after the S, and there are 4 oxygens, O4. So the ratio of hydrogen to sulfur to oxygen is 2 to 1 to 4. Let's have a look at another example. Glucose has the formula C6H12O6. So we're looking at the ratio of carbon to hydrogen to oxygen. We can see there are 6 carbons, 12 hydrogens, and 6 oxygens. So the ratio is 6 to 12 to 6. However, we can make this ratio simpler, and we should always endeavour to make ratios as simple as they can. If we look at this 6, 12, 6, we can see that all of those numbers are in the 6 times table. So we can divide all of them by 6 and we end up with a ratio of 1 to 2 to 1. So we need to always make sure we use the simplest ratio that we can. Perhaps the most important math skill you're going to come across in science is how to rearrange an equation. We quite often need to change an equation so that we have a different subject. We're generally only going to be looking at 3-part equations at the moment, and we can use a triangle to help us. So, let's take an equation from physics. Speed equals distance divided by time. Just note I've also included units here because it's really good practice to include units. I can also write this as S equals D divided by T. Now, let's think about our triangle. There are 3 parts to it. Now, in maths, when something is on top of something else, it means divide. This is going to be true for our triangle. When something is next to something else in maths, it means multiplied. So this is going to be true for our triangle. Now let's look at our equation. Speed equals distance divided by time. So, distance can go at the top of our equation because it's distance divided by time. So time must also go at the bottom of our equation. So we're taking this idea of distance divided by time and we're putting it into our triangle. There's only one space left now, and that's for speed, so that also must go at the bottom. We can now use this information to work out any other part of the triangle. So how are we going to do that? Well, we cover up whatever we need to be the subject of an equation. So, whatever is left in the triangle tells us the equation we need to work it out. We already know that speed equals distance divided by time, but let's cover up speed and we are left with just distance divided by time. So speed equals distance divided by time. If I want to work out distance, I do the same thing. I cover up distance, and what am I left with? I'm left with speed times time. So I now know that distance equals speed times time. My final equation is making time subject. So again, I must cover up time. And I'm left with distance divided by speed. I now have three versions of my equation from using the triangle. You may find that you don't need to use the triangle. You may find you know how to work things out otherwise, but it is a very, very useful tool. Standard form is a way of writing very large or very small numbers and to show them easily. So let's take a really important number in science. It's called Avogadro's constant. It's also known as a mole. And we've got 6, and then we've got lots of zeros. So let's count them. We put it into threes. That makes our life a little bit easier. So we can see the 1, 2, 3, 4, 5, 6, 7 threes. So 7 times 3 is obviously 21. And there are 2 more zeros after that. So there are 6 and then 23 zeros. This is a big number. It's not easy to read. So we can write it in standard form. And standard form is 6 times 10 to the power of 23. So this number is exactly the same, but it is written in a slightly different format. So, if we want to write the number 2 million in standard form, we can do it very, very easily. We first of all put a decimal point at the end of the number, right at the end. We then move that decimal point forward until we get to the first number. So we can see this decimal point needs to move forward 6 times because there are 6 zeros between the decimal point and the first number. So it goes forward 6 times. And this is equal to the power. So this number is going to be written to the power of 6 because the decimal point has moved 6 times. We remove all the zeros. So what we're left with is 2 point. We can now add the power in. And to add the power in, we remove the decimal point, we put a multiplication, we put the number 10, and then we put the number of our power. And that number is equal to the number of places we move the decimal, in this case 6. So, we are left with 2 times 10 to the power of 6. This is our number 2 million written in standard form. Let's try another number. Let's try 2.5 million because it's going to be slightly different. We're still going to follow the same procedure. We're still going to put the decimal at the end, move it forward, and remove the zeros. So, exactly the same, but we've now got 2.5 million. So, decimal place moves forward 6 places because we need to get to the first number. We now remove the zeros. And there are 5 zeros that are removed. So we have a power of 6, so we are left with 2.5. So we put in our power, times 10 to the power of 6. So 2.5 million is written as 2.5 times 10 to the power of 6. If we have a number that's less than 0, standard form still works in a very similar way, but instead of having a positive indice, we have a negative one. The indice is just the power, basically. So, let's look at this number. We're going to do exactly the same thing, but instead of moving the decimal point forward, we're going to be moving it backwards. So, we keep on moving it until we reach the first number that is not a 0. So let's see. In this case, how many times has it moved? 5. So we're left with 6.7. So it's moved back 5 times. Now the power is going to be negative because it has moved backwards rather than forwards. But the power is still equal to the amount of times it's moved. So this time it's going to be times 10 to the power of 5 because the power has moved 5 times. So we remove all the zeros just like before. So 6.7, we add our power times 10 to the power of minus 5. It must be a minus because the number has moved backwards. So, in summary, math skills are vital for science. You should be able to do all of the things covered in the lesson, and then there are a few other things which are incredibly basic, and hopefully you know how to do those already. If you struggle with your maths, the best thing you can do is to keep on practicing. Practice really does make perfect here. So, I hope I've made science easy for you. I hope you've learned a lot in this lesson. Until the next time, keep learning.